All right, here we go. Now, these first questions are not in your notebook. Guys, are these in your notebook? No. However, on the worksheet that I created for you, your assignment, I did put questions like this on there, so I was pretty sure you can handle them. And I was debated, should I just give them to them? Are they going to struggle? Let's review just in case. So geometry, we're learning all about notations. So right here, if you know that GH equals 4, technically you could put a little 4 in there, right? If you know EF is 4, you can put a 4 there, yada yada. HE is 6, GF is 6. Thumbs up, that part makes sense, right? Okay, I feel like any math student can do that. But you're a geometry student, so now we're getting into the notation of things. Guys, if this segment is 4, and that segment is 4, they are, can you use a vocab word? They're congruent. Good job, I'm impressed. They're equal, congruent, that's fantastic. Okay, but there's a notation for congruent segments. Do you know what it is, Kelsey? Yes, congruent is that equal sign with the squiggly, right? So there's congruent. How do we mark it on here, though? Just with the symbol that those are the same. Heather, what do we do? Yeah, that would totally work. So like this, is that what you mean? So if that one has 2, then this one has 2. It's saying this piece equals this piece. Thumbs up, does that make sense? Okay, well check it. Do you agree top and bottom are equal? Okay, watch. Can I do this? Can I put 2, 2, 2? No. Why? They're all equal, right? That is misleading. Not saying that's 4, 4, 4, 4, but they're not. If I snuck in one more, is that okay? Yeah. Or could I have just done 1 on top, 1 on bottom? Yes. So you're okay. You'll survive those ones. Next one, number 2 says N is the midpoint of PQ. Stop. You need to know the definition of midpoint. What does midpoint mean? It's the middle of it, right? So if N's right smack in the middle, what do we know about this and this? They're equal. How do you mark it? Check, check. Good enough? Okay, on this last one, AC equals BD, I might blow your minds. Are you ready? I'm going to go slow and I will try not to lose you. Do you remember when we did the segment addition postulate? So AC really is AB plus BC. Do you remember doing that? You okay with that? It's this piece plus this piece? Okay, so I can write it like that. And then instead of writing BD, couldn't I just write BC plus CD? Huh? So I've just been a little more descriptive about those. Well, check it. If this was an algebra problem, could I subtract BC from both sides? Could we? Is there a BC on both sides? Yeah. So after you subtract BC, what are you left with? This one took some work before you can put notation on it. So if AB equals CD, check, check. What? Thumbs up, did you follow me on that one? Okay, one more symbol, it was kind of weird. One more symbol that I realized comes up on your worksheet. Do you know what this means? Perpendicular! What does perpendicular mean? 90-degree angle. So how would you mark it if that's all it said? Like, for example, what if it says that in this picture, PN is perpendicular to, I guess it would be more like PQ is perpendicular to NM. What if that's all they give you? How would you put a notation on there? Tyler, what are you thinking? Yeah, that's it. Boxy box box. Done. Yeah? You okay with those kind of questions? Because I realize it's not in your notebook. All right, let's go to our vocab. We've talked about theorem. Do you remember? Tyler like wowed the world with theorem. So let me move this up. So we're talking about proof. Guys, theorem. A theorem is a true statement that comes from other true statements. Write it down, write it down. Garrison, you got it? Write it down, write it down. This one, I don't want you to copy, so write that down. I'll be blocking this one out. Go, go, go. Here we go. 2-column proof. Raise your hand. Have we done 2-column proofs in this class? We've been doing them forever, right? So just be nice to yourself. 2-column proof looks like what we've been doing. Statements on one side, reasons on the other side, and we've just been organizing it in a T-chart. That's a 2-column proof. Okay, the other type of proof is a paragraph proof. I'm going to admit right now, I do not love paragraph proofs. I'm a more organized person. I feel like the statements reasons it's very organized and easy to follow. The paragraph proof is like you took statement 1 and you wrote a sentence for that. And then you took statement 2 and then you were like, then number 2, blah, blah, blah. And then number 3. So it's a sentence for every single one until you create a paragraph. Do you see that? It's like the same thing but not as organized. Blah. Takes longer, I feel like. So if you're ever asked to give a paragraph proof, just use your 2-column proof and change statement 1, reason 1 to a sentence. Like, well, CD equals AB because it was given. And then BD equals AB because of yada, yada, yada. You just add in your vocab, okay? All right, let's go to this part from yesterday. Can you handle filling those in? We talked about reflexive, we talked about symmetric, we talked about transitive. I'll pause it, try to fill those in from yesterday. Okay, reflexive, can I get a hand in the air? If they give you AB, do you remember what the reflexive property is saying about that AB? Kelsey, what is it? Yes, good job. AB equals AB. Literally the exact same thing on both sides of the equal sign. Okay, symmetric, remember I told you that weird story yesterday, so hopefully it'll help you remember. So AB equals CD, then do you remember what to do with symmetric property? You guys shout it out, what is it? There you go, good job. CD equals AB. You do the exact same thing, but you flip it. Symmetric property, we got your line of symmetry, it's the same thing, but opposite. Transitive property is exactly like the law of syllogism. So if they both equal CD, this is what Annie did on the board. If they both equal CD, you can take this out, and say AB is going to have to be congruent to EF. We're being more specific, so this is for segments. We'll use these in our proofs today. Okay, here we go. Our first segment proof, it's the bottom of page 41. I kind of love these proofs because they're fill in the blank. It's a little bit rough if you have to come up with your own proof. So here we go, our advantage. Okay, we've got all this going on. It says we can use the transitive property to show how all of these are congruent to each other. They get us started on the proof. JK equals MN. MN equals PQ. Where did that come from? What's our reason? Given. Always look at the given, right? For the first reason. It literally came from right here. So first reason, they gave it to us. Easy enough. Okay, those of you who were here yesterday, those of you who were absent, this is the one that I told you yesterday. Find this step lane. I don't understand why we have to do it, but it comes up all the time. Look, the only difference between number 1 and number 2 is number 2 is missing stuff. Do you see that? It's just missing the notations. Do you remember the reason from yesterday, though? Do you remember what it was? Allie, what is it? Yes. If that's the only thing that has changed on your proof, then that is definition of congruent segments. There's got to be a reason to it. If nothing else, they're easy to figure out, right? Just take off the notations. Okay, next one, our clue on the reasons is they use the transitive property. So look at number 1. Actually, I'm going to look at number 2. So number 2, guys, shout it out. What's the similar part of the segment in number 2? They're both using it. What is it? And then, so take it out. Andy, what can we say for number 3 then if we take that out? Perfect. JK equals PQ. And then last step, they did it for us. They put on the notations and they put definition congruent segments. Thumbs up. Did you survive your first segment proof? You okay? Question. Did you have a question, Heather? I don't know. I probably should know, but I don't. I don't know why they're on and off. Okay, let's keep going. Our next proof. Okay, here we go. This is a confession. When I get to proof, sometimes I'm like, crap. I don't know where that came from. Crap. I can't figure out what that is. And then I realized. So this is one where I put on your notes and I was like, do I remember how to do this? And I was like, oh my gosh, I'm being so dumb. So number 1, PQ equals RS. Check, that was given. And then all of a sudden they say PQ equals QR. Do you know why? It's given. So if you're ever like, what? That came out of nowhere. Go back to the given. Look, it came from right there. Okay, next one they're saying transitive property. So what did they take out of number 1 and number 2? Do you see it? Yeah, they took out PQ. Take out PQ, you can say RS is congruent to QR. Okay, and then again, I'm like, where did PS equal RS come from, you know? That one's also given. It came from right here. Look, literally it's the exact same thing. So that one was given. Looks like this proof is pretty much done for us. Again, they use the transitive property. What did they take out of this one? Oh, it looks like they took out RS. Do you agree with me? That's it, PS equals QR. Thumbs up. Did you survive your second proof? You okay with this one? Okay, let's do one more proof. This one is a doozy. Are you ready? You have a little more room than I have on the board. Let's do this proof for our last proof. Whew. Okay, Now I gave you a few more hints on the board that's in your notebooks, so let's do this together. So right up here, it just has a sentence for us. AC equals CE, check, and AB equals DE, stop. Put that in your given. They gave that to us. We'll just write the math part of it up. Okay, and then it says, show that C is the midpoint of BD. All right, so we're trying to prove, literally, that C is the midpoint of BD. There we go. So we got our first two blanks on. We're doing fine. So number one, 9 times out of 10, we always start with exactly what's given. So literally, AC equals CE. That was given to us. Okay, number two, AB plus BC equals AC. Guys, was that given to us? No, but look at the picture and let's talk about what's going on. They're saying this piece, AB, plus this piece, BC, equals this entire piece. That's a postulate I taught you in chapter 1, and I actually reviewed it when we were doing the notations. Do you know what it's called, though? What's the postulate where we can break stuff up? Ty, what is it? That's it. That's your reason. If they're just breaking something up and looking at the picture, your reason is segment, because we're talking about a segment, addition, postulate. Good job, Kyle. Hang on to that. That comes up, that comes up, that comes up all the time in proofs, especially segment proofs. Okay, let's be nice to ourselves. The next one, it gives it away. They say use the transitive property. Okay, so come up to step 1, step 2. Step 1 and step 2 have something in common that they equal. What is it? It's AC. So we can take out this AC. Take out this AC and we can put these two together. So AB plus BC equals CE. Transitive property says take out what they have in common, put the other two together. Okay, number 4, again, I feel like where did that to the picture? Picture it's saying this piece plus this piece equals that piece. Guys, what's the reason for that then? Yeah, good job. Be confident. Segment, addition, postulate. Okay, number 5, I helped you out with that one. So number 5, the reason. Since we're using transitive property, we can say AB plus BC equals CD plus DE. So between number 3 and number 4, what did they both have in common that I took out for you? Can you see it? Yeah, totally. So I took out this, made those other two equal. Number 6, I feel like that came out of nowhere. AB equals DE. Do you know the reason on that one? It's given. Good job, Abigail. Totally given. Came from right here. Alright, so that one's given. Okay, the next reason, this is another giveaway, but I'll tell you why it's substitution. So the next reason is substitution property. Look what's going on. So right here, it's the exact same thing. AB, AB. BC, BC. CD, CD. What? Right here, we know that AB equals DE, so we took out DE and we put in AB. That's substitution. Literally, take something out, put something in. Do you see that change? That's the only thing that changed. Okay, number 7, just look at it from your algebra viewpoint. Number 7, it's giving it away, subtract something out of there, but it's got to be on both sides if it's a subtraction property. What's on both sides we can take out of there? AB's on both sides. So subtract AB from both sides and we are left with, yeah, BC equals CD. Guys, good job. I'm super impressed. Number 9, grumpy. You know what number 9 is for the reason? Not the reason. The reason is definition of congruent segments. Do you know what the statement is? Yeah, it's the same thing, right? Segment BC, good job, Tyler, is congruent to segment CD. That's weird, I think. Okay, last one. I can't remember if we did an example of this yesterday. Last one we finished. Since BC equals CD, since we now know that this equals this, well, obviously, C would have to be the midpoint. Do you agree with me? So what do we write for our reason? Are you ready? I think you guys know that because you know this word. You know what midpoint means. Do you agree with me? So this one you literally can put definition of midpoint. You know what that means. That can be your reason.